So example 10.1.1, so making a scatter plot. So is there a relationship between the alcohol content and the number of calories in a 12-ounce beer? So again, alcohol content, we have a quantitative variable, and number of calories we have, again, is another quantitative variable. So we've got two different quantitative variables on the same object, a 12-ounce beer. So to determine if there is one, a random sample, okay, so when we get to inferences, again, that's important that we have taken a random sample, was taken of beer's alcohol content and calories, and the data are in the table below. So we've been asked to make a scatter plot of this data. All right, so in our list here, we've got 3, 6, 9, 10 different beers that were randomly selected, and their alcohol content is recorded, and then the calories in each of those beers is also recorded here. All right, so in our solution, again, we're going to first define, again, thinking about defining random variables, and when we get into inferences, defining our parameters. So in this case, our random variable x here is going to be the alcohol content in a randomly selected 12-ounce beer. And then our random variable y is going to be the calories, or we could put in here, number of calories in that same randomly selected 12-ounce beer. So again, we're getting two measurements on the same object, but a little bit different than in the paired study. We had the two measurements were of the same variable. So where we looked at, weight before and after a diet plan or something like that. Here we've got two measurements on the same object again, but they're different variables, alcohol content and number of calories. All right, so if we make our scatter plot, so here we've got our title, and down here our alcohol content was our random variable x, and our random variable y here was the number of calories in that beer. And we kind of look at this and we've got, here is, 3, another 5, another data point, but then we kind of have this data point over here that's kind of off by itself. And as we're looking on the alcohol content percentage, it's almost nothing. So this scatter plot looks fairly linear. I'm going to say except for that one point there that's kind of far from the rest of the data. So we should notice that there's one beer in the list that's actually considered a non-alcoholic beer. So that value is probably an outlier. It's way far from the data since it's a non-alcoholic beer. So the rest of the analysis, we're not going to include O-duals. Now, we can't just remove data points because they're kind of a pain in the butt. But in this case, it makes sense to do so because all of the other beers have a fairly large alcohol content. So in this case, we're looking at, this relationship between alcohol content and calories. It makes most sense to look at beers that actually have a higher alcohol content and not something that's advertised as a non-alcoholic beer. So now if we look at the scatter plot without the O-duals beer in there, whether we use our TI-84 or whether we use StatCrunch, again, the relationship here looks roughly linear. Remember, we're not playing dot-to-dot linear, and we're going to look at actually getting a way to measure the strength of that linear relationship later. The next step is to find a line, since we're looking at linear, find a line that best fits the data and the corresponding equation of that line. So we're going to find this kind of line of best fit and then the equation that goes with that particular graph. So in high school algebra, you spent many, many months every year on linear functions. And most of you are familiar with the equation y equals mx plus b. That is used in most of the algebra texts. Okay, some of the more current algebra textbooks use the equation y equals a plus bx. So let's give that some highlighting here to find later. And this matches the equation that the calculator uses and the linear equation that we're going to use in this particular class. So just as in algebra or in a science class, okay, x is what we call the independent variable. And in stats, we also call it the predictor variable, because it's going to help us predict some output of y. And y is called the dependent variable. Its value depends on the given value of x. And in stats, we also call that the response variable, because in statistics we change the input variable, the independent variable, and we see how y responds to see if there's any predictable pattern there. Now the coefficient of x is the slope, and the constant term gives us part of the coordinate for the y-intercept. So it doesn't matter whether we call these things m and b, or down here we call these things a and b. Okay? And up here m is the slope and b is the y-intercept, but now in our new equation here a is the y-intercept and b is now the slope. Okay? But it doesn't matter what letter names we put with those things. Again, it's always the coefficient of x, so the constant in front of the variable x that gives us our slope, and the standalone term that gives us our y-intercept.